Okay, we're busily working on files here. We had this idea yesterday that you basically, when you want to write any of these classes that we're making to a file, you have to, in our case, currently write it as a text file with one record per line out of the list. And then when you want to read it back in, you have to read in one line of text at a time and grab the constituent parts and turn them back into a new object and then add them to a list in order to get back what you'd written out. Okay. Just as a sort of a Java skill, I want to turn around and clean this up a little bit. This program is sort of really currently in three parts. It's like we make a list as sort of test data, and then we write it out, and then we turn around and read it back in, and then print it out. So 4 pieces. And this sort of naturally occurs with coding as you go. It's like, oh, okay, I'm just going to get this to work. But what I want to do now, just for the pure Java fun of it, is split it up into a bunch of methods. Okay, just to get that skill, because this is where it comes in handy. So let's just leave the part about building the array, and let's concentrate on this piece here, which is really a write-out file. Okay, because it opens a print writer and then does a bunch of stuff. So let's just change this to a method. Okay, so one way or another, this is going to be write out file, and I'll show you the process that I use to start doing it. So all that I do is I take all of this code and I say, oh, I guess that meant write out file. Okay, so we'll just cut all of that out there, and we'll find some place down at the bottom of the file, and we'll write a method. It doesn't matter what it is, private. It's got to say static just because I've only got a main program. Void write out file, and paste all that stuff in. Okay, so it's exactly the same code that we had, except that now there's a couple of things it doesn't know about. So as soon as I get a couple of things that it doesn't know about, I go back up and I say, well, let's see, file name was actually string file name. So I'll just take the declaration for that thing and I'll put it in there as an argument, and that makes that error disappear. And I'll go, oh, well, all students, if I go back up and look at what all students was, it was declared as one of these things. So we'll copy that and we'll paste that back into here as another argument. Those are the things that I need. Oops. Okay. And we won't worry about that for a second. And then write out file here now has to take both the file name and all students, more or less, other than that one little IO exception. Okay, so that's the easiest way to do it. Okay, and I don't know if we've ever actually done that before, so wanted to make it clear. And it helps to just keep the same names. The names don't hurt. They're actually different variables at this point when they go into the method. Well, sort of, kind of. But in general, that's just the easiest way to do it. Now we've got this one little error here that says we haven't really caught that. So we'll just add the throws onto the end of this thing, which just basically sends it up to the main program. And now all of a sudden we've got write out file. Okay, so one more time we'll play the same game for this is make a list. So all of this stuff here is read in file. Play the same game there. Oh, okay, it goes down to about here. Looks like this is all read in file, so we'll just cut that out, move it down after here as private static void read in file, paste all of that goodness in there, and then go and say, oh, well, what's missing is it looks like I have to supply a file name to make that happy. This is probably going to be upset about needing a throws. We'll just kick it up to the main program for now until we figure out how to do a better job of that. And then go back up here and go, well, read in file takes a string, a file name variable. Okay. But in this case, if you go down and look at the code for read in file, the result of reading in a file is an array list. Okay, so I'm just going to change this thing to say, oh, well, I need to send copy of students back. So instead of void here, I'm going to send something back. And then down at the bottom, I'm going to have to say return copy of students. Okay, which means up top here, what I'm going to get is, see if I get lucky, a list that's copy of students. And there's an example of taking a function or a method that returns a value instead as one of the things coming back. Okay, and I've just succeeded in splitting that thing up into at least a couple of nice pieces, and now look what happens to the main program, right? The ideas have been separated out into, oh, this thing we could actually turn into make test data if we wanted, and then this is just go through all of the things that we copied and print them out. Okay? So there's an idea also of that self-documenting feature. I haven't added any comments yet, but I certainly managed to clean up the code and make it more readable. And now if somebody wants to figure out how I wrote out the file, they can always go look and see what I did to write out the file. Okay, and that's what I mean by cleanup. It's really sort of typical to write sort of cruddy code that just goes in line and tries to do something, but then after you've got it to work, that's the time to start turning it into at least something reasonably nice. Okay, so questions about that? Does it still work? Well, hopefully. Okay, so it still manages to produce some output, which I'm just going to sort of assume is correct. There's the Fred, Barney, and Wilma from before. Okay, happy with that? Okay, so now we've reached the point where we've got this thing sort of half decent. I wonder what happens if we make some errors. Okay, so let's try doing something here like with the file name. This is written to the current directory. Let's just do this, and since this is a Linux system, this is now trying to write it to the root directory. That's a path name. Okay, so I don't have permissions to write in the root directory. So what's going to happen?
It's going to error out.
It's going to hopefully produce some sort of error. Your two choices are either it's going to quietly do nothing, or if life is good, maybe it will produce some sort of error. So let's just run it and see what happens. And there's the error down there. I'll see if I can get all of it on the screen. It says, conveniently enough, permission denied. Okay, so notice that this is still a stack trace as normal. And again, with the stack trace, you can follow along and go, well, okay, let's see, I don't own print writer, I don't own any of that stuff down there, but I do own student file driver line 30, so there's the line that's currently causing the problem. And so it's actually the main program that caused it. So this is an example of it's really not this guy's fault, it's the main program that sent some garbage down, namely a file name with a slash on the front of it, and this thing just happens to get flagged for being in error at that point. Okay, so yes, these things still manage to die appropriately. So now the question is, well, how do we fix them? Okay, and let me just go into this class, and let's see if I can maybe do a little dirty work here. What have I got? File not found exception. What's it actually getting? It's getting a permission exception. Okay. Let's just leave that one, and I've got a little separate example here where I've merged these things back together, just because it'll be a little easier to deal with for a start. What I did is I copied some sample text here, so I've got the old file driver that we used to have, same sort of scenario. This is just the simplified version with print writer to write out some stuff to a file that we started with before we started writing out students. And there's the, oh, okay, now let's go try to use the scanner class to read it back in. I just wanted this stuff in line in one small thing because it makes it just a little easier to see. So same thing there. We'll put a slash on the front of this thing to cause a problem. And there's the problem. It still says permission exception here somewhere. There we go. Okay, so now in a normal program, it would sort of make sense to actually deal with that error. And so I'm going to see whether or not I can at least catch that error and do something about it. And so let's start out by removing this catch of IO exception here. Okay, malformed URL exception was for old stuff. So we end up with a program that looks like this. And remember when we started with the program, we said there were two choices. One of the choices that the bulb gave us was add the throws, which is what we've been doing, which just said, I don't want to deal with it. The other option is to say, well, I guess I should do something about it. And that's this option surround with try catch. Okay, and what happens with this thing called try catch is it's sort of like in some senses it's going to turn into a sort of an if then else for error processing. So this is really sort of an if statement. This says try to do that particular operation. And if for some reason it fails with a file not found exception, then this is what we're going to do as a result, which is just print the stack trace, which is what you saw. Okay. Now the reason it's upset about these is because when it surrounded the stuff, it didn't actually put these in the right place. The IDE didn't put them in the right place. So I'm just going to move them in there. Okay, and I'm going to go down and I'm going to do the same thing to the scanner, the input part, is I'm going to surround that with a try catch, and I do play the same game. I'm just going to drag this stuff back up where it belongs inside of where that variable is more or less visible. Okay, so you end up with something that sort of looks like that, minus that comment that we don't need. Okay. Notice something interesting about what happened to the code immediately? Easier or harder to read than what we had last time?
Harder?
Yeah, a lot harder, because now all of a sudden it's sort of the, you know, there's all sorts of bracy stuff in the way, and it's just a lot harder to see what's going on, which is another reason for splitting those blocks up into one's read file and one's write file, and what do I do about it? Okay, but this says now I want to deal with the error. The current way of dealing with the error is just to print out the stack trace like we've done before. Okay, and so after having done all of that, if we just turn around and run it again, oh gee, we still sort of end up with almost exactly the same thing. We get a file not found exception permission denied on myfile.txt, but oh, what happened here? This didn't happen before. The program continued to run. Okay, it didn't die like it did in the previous case. It continued on to do stuff. So the other thing that happens with try catch is, in this case, the catch says, I'm going to deal with it, don't consider it an error, just print out some error information, and then continue on by trying to do a read. And it just so happens I left the other one with that old file that we did from yesterday, so it was still around, perfectly capable of reading the file. Okay, so there's the couple of differences. One of the big differences is that you can then turn around and decide what to do about it. Okay, so just to show you here, we could do something. Just let's stick a print statement in here. Just to show you that this is where we put whatever code we want. And I'm just going to take out that line just for a second, and we'll see what happens. Okay, so now I'm not printing out the error anymore, the sort of the typical Java error. I'm just pretending that I somehow dealt with it and continuing on the way. Okay, questions about that? Okay, now let's talk about these things in here. There's a general class of these things that's called exception, that refers to basically the root of all exceptions. And then the other ones are actually inherited classes. So we're back to this idea of inheritance. So file not found exception is a specific type of exception that only refers to files not being there, so it can do special things. So you have your choice when you catch exceptions of, you can catch something up high in the hierarchy and go, I'm just going to deal with any old problem, or you can catch very specific things by making this catch more than one specific exception. Okay, so you can say, oh, I just want to deal with file not found, and I just want to deal with permission here, and anything else will still kick on up the hierarchy to the higher level exception. Okay, so you can split it up into any level of detail that you want, basically. Okay, so sometimes you want to catch something that's just the big picture, and other, any old thing will do here. It's a problem, let me go and redo it. And in other cases, you want to be very specific about the kinds of things that you catch. Okay, so I think we can actually probably change this to, if I'm lucky and I know what I'm talking about, we can change this to just exception, and it will still produce the same thing, because that's the more generic idea. Okay, and there's actually IO exception, which is probably even better in this case, so that only refers to things that are directly related to IO. Okay, so work your way back up the hierarchy. Finding out what these things are is sort of sometimes a little difficult. Okay, the other thing about them is that if you leave this exception object is actually an object, and so it has all sorts of interesting things that you can do to interact with them. So get localized message is I think gives you localized in this sense. I think, if I'm right, refers to in a different language. Okay, versus get message is the message that we actually saw. Okay, so for instance, let's just do that. Let's just, instead of printing out a stack trace, let's just change this to plus e dot get message, for instance. Okay, and we'll run it again. Okay, and so that's the same error message that was in the stack trace, except without the cruddy stack trace in there, because that's sort of a programmer thing, and these error messages are quite often more of a user-based thing. Okay, so that would be, sort of typically the way it's used. Now, the other thing here is that you have the ability here to do things to fix the problem. Okay, so for instance, you can start to play games that you'll often see, like where they'll put this in a while, some file read or written, I guess. You could start to play this sort of game where you make a Boolean. I'm not going to do all of it here, but we can say Boolean file written equals false. This would be the successful case, so you could say file written is true there, and then actually that might just do it. Something along that line, and something here like this is enter new file name, whatever it happens to be. Use a scanner or do whatever you can, if this was user input, to change the file name at this point, and then go back up and do another try with a different file name in here to see whether or not you can successfully open the file. There's no cancel ability in here. This is just an infinite loop until they do actually open a file. But you'll see something along that line quite often where the while loop is to just keep going. Well, that one didn't work. Let me try again. Let me try again. Let me try again. Okay, and now I'll just get rid of all that because it's sort of not important at the moment. Okay, but there's the sort of the standard thing that you'll see. And so in this case, what probably wouldn't happen is I probably wouldn't even continue on. Or the other thing that you'll see is that now that I've been successful here, you might take all of this stuff and put the reading of the file in here instead. Right? So move this entire clause of stuff that tries to read the file up in after you've successfully accomplished that inside there. So it's still okay to nest them if you want, although sometimes weirdness results. Okay? And the other thing that you'll see while we're on the subject is that there's also a finally clause. And the finally clause is the chance to do something whether or not you succeed. So for both success or failure, regardless of whether it was if success, else failure, this is now the cleanup clause that allows you to do whatever you want in either case. Okay? And you don't have to write that, so I can leave it off. And the other thing that you'll see is that you can also do more than one catch. So you can do catch, we'll do the generic one. So you can also play that sort of game. So now you can have more than one catch clause for different types of things, and they just go in order. So that's the more specific one in that case, right? We'll try to catch that one first, but if there's a more general error that's not that specific one, then you can catch any of the general errors in there and do something about it there, whatever it happens to be. Okay? So somehow deal with it locally. Okay, so also multiple catches thrown on there, all sorts of variations. Okay, this tends to be used in place of the old style thing that you would see, like for instance in the Unix world, if you try to read something from a file, it gives you a -1 error return if you don't succeed. So those functions that you see that do error returns coming back, that was the old school way of doing it. And that meant that people always had to check for errors from anything. This is sort of the, I can catch a whole bunch of errors idea if I want and make the code look a little cleaner, because you can just say, well, okay, this is a whole bunch of stuff instead of just one idea, and then let me catch it. Okay, so now you have your choice. You can either decide that you know how to deal with the error and you can somehow correct it, or if you don't feel like dealing with the error, you can do the throws clause and send it up to some higher authority and say, just let it go and say you deal with it. Okay, so throws tends to make the code cleaner, and so this stuff typically gets hidden inside methods, which is why I showed you the idea of burying those things into methods to deal with the specific errors that you might encounter. Okay, questions about try catch so far? Okay, one other thing that you'll see happen is that. What do you think is going to happen? To the program when I run it?
It won't print anything, but it'll just not fail when it's the error.
Yeah, this is just ignore the error. Okay, generally a bad thing to do, because now you're just letting something cascade. So in this case, it just so happens I have my file.txt anyway, but if I delete my file.txt, then all of a sudden this thing is also going to error out. Oh, what the heck, let's just do that. So let's just delete that thing. Okay, and then we'll run it. And now, if you look at the thing that, oops, wrong line. If you look at the thing that died, it died now on the open with, oh, look at the message. No such file. Okay? Because I was unsuccessful in writing the file to start with. I didn't put it in the right place. It's not in the current, there's no file by that name in the current directory. I ignored the exception, and now it just ends up causing a problem later on. Okay? So this is the worst thing that you can possibly do, and you should sort of be very careful about never doing that. Although you'll see a lot of people that do it in their code, largely because if we go back to this before the finally, oops, I'm just going to create myself even more of a problem here. Just want to put it back to something that it will eventually keep. If you do the, whatever it was, the, I guess we have an example down here. This is probably better anyway. What happens is you get the automatic code generating things that turn around and write this for you, like Eclipse did. And so what will happen is people will leave that in there thinking that, oh, okay, that's dealt with the error, when in fact it really doesn't deal with the error. It just prints out a nasty message and continues on its way, right? And so what you can get in sort of non-GUI code, or sorry, in GUI code, is you can get behind the scenes, the error is still being produced, but it's just not visible anyplace, and then all sorts of weird things start to happen. Okay, so be very careful when you see either empty catch clauses or catch clauses that just have this in it, because it means that somebody's just taking the default and really not dealing with the error. Okay, any other programming languages? I think that's probably the first time you've seen that idea, I'm guessing.
I've seen it in Null before.
so far. Yeah, it comes up in other programming languages now start to use that a fair bit. It's not in the older programming languages. So for instance, there's nothing like that in C, for instance, that has that sort of capability. Okay, but those are the two differences really. Throws is don't deal with the error, send it above, and try catch is, oh, let me see if I can somehow look at the details and see if there's something that that I can do. Okay, covered that. Next on my list of goodies, let's suppose that we want to find, let's go back to one of these other examples here for a second. Let's go back where we wrote out the students. And let's talk about, yeah. Okay, so here we had a list of students, and they had a bunch of students, Fred and Barney, and now I make a copy of this stuff. What if I turn around here and I write out to a different file my copy of list into some other file? Okay? And now that means that I've essentially got the same information duplicated in two files. Fred, for instance, information now appears in two different files because they were really two different lists, and we talked about writing things out into, you know, different places to keep things separate. We thought that would be a good idea, right? Well, what happens now if I read each of those lists back in independently when I start up my program? Anything interesting about Fred and Barney? Or Fred and Barney from the two different lists? They're duplicated. So what happens if I run equals on, right now, if I go through and I run equals on Fred from this list, if I make a copy of the list in the normal way, by just say, you know, internally within the program like this, if I say list of student a copy is new array list using all students to start with. What's the difference between the Fred that's on this list versus the Fred that's on this one that I just read back in terms of equals?
They're the same.
Address.
The only thing is together, just in different memory addresses.
Well, let's just give that a try, just out of interest's sake. If I do, do I have an equals? I just better check and see whether or not I have one. Yeah, just looking, is there an equals? No, there isn't. Oh, well, we'll do it in any case. If, I actually have to get it. Let's get the 0 item out of that list. Fred 1. And we'll get the 0 item out of this list. This is Fred 2 now coming from a copy. If I say if Fred 1, I'll even mess you up even more. Use that generic word, the same. True or false?
True.
Is it going to print out Fred 1 and Fred 2 are the same?
Well, not at present, because you were comparing the memory addresses using the default equals.
Well, let's go back. I mean, in the first case, the question is what equals is this? So let's go back into the student class and let's just see whether or not we have an equals. No, we don't. Okay? So this thing is actually the same in this case as if we'd done double equals, which is the default. True or false?
False.
This is the one that was the internal copy from all students. Let's just run it and see. This is what we originally did. So the question is, why are these the same? They're pointing to the same place in memory, right? So when we copied this list, we've got two different lists, but they refer to the same people, right? Because we copied the phone numbers out of the address books. Okay? That's what we've sort of traditionally done internally. Okay? Well, now the question is, if I do the same thing down here when I read in the file, and this time I'm going to get it from copy of students. And this is, we'll have to call them Fred 10 and Fred 20. And I'll just do the same thing with Fred 10 and Fred 20. Is it going to print out Fred 10 and Fred 20 are the same?
No.
No, because
Because you're rereading it back in and it's not becoming the
There's
same.
no way of knowing that for the computer to know that it was the same.
yeah. So it doesn't print it out. I ran it and it doesn't print it out. And if we go down and look at the place where we read it back in, what's the interesting word of all of that stuff that explains it?
It's new.
There's new. Because when we read it back in, we use new to create new objects, which are by definition different from the originals.
They have the same data.
Okay, so they have the same data, but they're no longer the same. So equals will work if we write an equals method in the class, which is sort of fine for most purposes. But what if we read in Fred a whole bunch of different times for whatever reason? Fred was, I don't know, Ellen with Twitter or something. 1,000 or a few million retweets of something, so her name gets mentioned all over the place, and we were sort of processing her stuff from the file. We're going to end up with a new Fred over and over and over and over again, but really we're going to tie up our memory with all of these multiple copies of Fred, who really should be the identical Fred rather than a copy of Fred. Okay, so what do you really have to do here if you want to prevent duplicates?
I have to check if one already exists.
You have to check here, instead of before you do a new Fred, you have to check and see whether or not Fred is already around someplace in memory. And if he were around someplace in memory, we could just use like equals to find him, refer to the one that we already have, and then that would mean now we're back to the same state we were beforehand when we did that sort of simple thing up here, which is just duplicate the list in memory. Okay, so the unintended side effect of writing stuff out and reading it back in is that we no longer have an easy way of referring to identical anymore. And what we really need to do is find some way to reproduce identical objects. Okay, now or to put it in other terms, I mean, this isn't maybe this is a sort of an obvious case, but think of if I had a list of students that I started out with, and then my program also kept a list of people who were just generically at Camosun College, not necessarily students, but maybe instructors and various other things. It would become even more difficult to recognize that the Fred over here is identical to the Fred that's on this other list within the program. Okay, so this problem sort of magnifies. So it turns out that it's actually sort of a difficult problem to solve, because when essentially what we said is true. When you read back in, you have to see whether or not you've already got somebody who's identical to the one that you just wrote out. Okay, so what we're going to look at next is it turns out that in the Java libraries, there's actually a really, really easy way of writing out objects and reading them back in. And it will do all of the work for you. You don't even have to split up the object into its component pieces. You can just say, hey, write this thing out, and it'll write it out. The only issue we're going to have with it is that it writes it out in binary form, so it's not easy to look at. Okay. The advantage is you can write out a list that has 100 Freds on it, write out the entire list all at once, and when you go and read it back in, if the 100 Freds were identical to each other and just appeared on the list 100 times, it will turn around and only have made one copy of the Fred and made all of the rest of the list references refer to that one. So it's a very, very smart way of reading and writing things back in. It's very easy. It has the disadvantage that it writes object files, which means that it is sort of Java specific and doesn't work across networks and all of that sort of good stuff. But that's what we'll do tomorrow, because it'll take a little bit. And then after we figure out how to get out object files, we'll figure out how to use the same sort of technique to write out XML files, so that you'll now have a transportable way of getting your data back and forth. And with that, we're done for the day.